Project 2 KN. First requirement, show your data being classified into 5 folds for one of the data set. Okay, so here I just executed it and we see like 5 different data frame has been returned. Each has a 35 rows, and each fold has a 5 different classes, and each class has a 5 different rows for that. So 5 fold plus stratified example. Second, demonstrate the calculation of the distance function. So I'm just running 3 different cells right now and waiting for the output. Okay. So here I am taking the first data point and then the second data point just below it, and then showing the distance calculation for the distance after each feature run, and the final distance is written with the square root. And this is the row for that distance, 5 rows nearest neighbor written for that data point test instance. Third, demonstrate the calculation of your kernel function. Um, so I'm just running it right now. Yep. So the numerator calculation, denominator calculation, and the final Gaussian kernel calculation and the kernel prediction is basically the same one. Um, so here I'm just taking the one test row, row number 7, and some small instance training set. The next, demonstrate the example of being classified using KNN and show the neighbors returned as well as points being classified. So running the algorithm now. Um, okay. So here sorry, this is the point I'm going to classify it, and the nearest neighbor. Here I'm not showing the kernel, sorry, calculation of the distance, which I already showed it, but on the right hand side the distance and the ranking, and the predicted class over here is like we can see four paths, four row has a path as a class, and so the return class is the path for the data point which we want to classify. Next, demonstrate the example of point being regressed using the KNN. Show the neighbors. So uh, here is the point I am taking it, and then this is the 5 nearest neighbor returned for that point according to the distance and ranking. This is the kernel calculation for Gaussian, and this is the regressed value. Next, demonstrate the point being edited out of the training set, nearest neighbor. So I'm just going to run it. And yeah, so initial length of the data set is 21, and we can see the actual class and predicted class. If it is matching, then the dropping row from that basically sorry, not matching and then dropping the rows, and the reduced data set is the 10, and here is the reduced data set for the ENN, and I'm calling the ENN algorithm over here on the line number 3. Next, point being classified as a condensed. So on the first line, I'm calling the condensed data set, and here is a 21 is the starting point, and the whenever the class is not matching, adding the instance into the condensed training set, and the finally we will have the reduced data set. And this is the reduced condensed data set, which has like almost 13 rows over here. Finally, average the 5-fold basically KNN, ENN, CNN. I will just run it and pause the recording, and we'll come back to after once it is execution is done. Okay, result is back for the algorithm, and basically we see like for each fold it is giving us accuracy for each fold and for each algorithm. Over here I will just directly jump on the average accuracy for all these things. KNN 89%, ENN is 82%, and CNN is 18 again 89%, and rest of the detailed algorithm accuracy is available over here. I will just run the next one and pause the recording once again. Execution is started, and I will stop the recording. Okay, result is available for the KNN regression on the 5-fold. I am running it edited, condensed, and the normal KNN regression. Here is the detailed result for each fold, basically, and here is the average accuracy. We can see the CNN is doing better than the rest of the other two algorithm. That's pretty much for all the video demonstration. Thank you very much.